Good morning, students. Today we will start a new chapter of physics, that is chapter number 12, friction. Friction is not a new word for you. You have already studied about it in your previous chapter, that was force and pressure, in chapter number 11. There we studied that force are of two types. We divided force into two types, that is contact force and non-contact force. And in contact force, we studied about the two types of contact forces. One was applied force, or you can say muscular force, and the other one was friction force. Right? Now, you studied there that contact force is one of the frictional force is one of the contact force, isn't it? Now, applied force, so we studied that applied force is a muscular force, isn't it? That is an force applied by your hand or by your touch, direct contact. Similarly, friction is also a contact force, that means a direct touch by two surfaces. Then a frictional force will develop. Now, to understand the topic more clearly, let us see some of the examples of our day-to-day life. You might have seen a driver of a car or a truck slowing down the vehicle at a traffic signal. You too slow down your bicycle whenever needed by applying brakes, isn't it? Have you ever thought why a vehicle slows down when brakes are applied? Not only vehicles, any object moving over the surface of another object slows down when no external force is applied on it. Finally, it stops. Have you not seen a moving ball on the ground stopping after some time? Why do we slip when we step on a banana peel? Why is it difficult to walk on a smooth and wet floor? You will find all these answers to such questions in this chapter. Now, to understand it, let us do this activity. Keep a book on a table and try to push it. After some time, the book will stop. That means that some force is working opposite to the direction of the book moving, isn't it? We can again try it. Push a book in one direction, again it will stop. Now we come to know that the force must be acting on the book opposing its motion, isn't it? This force is called the force of friction, right? Now you saw that if you apply the force along the left, friction acts along the right. If you apply the force along the right, the friction acts along the left direction. That means the force is opposing the motion of the book, isn't it? The force of friction always opposes the applied force. Means in the direction you are applying a force, you are pushing something, the frictional force will be working opposite to the direction you are applying a force, isn't it? Now, is the friction the same for all the surfaces? No. It depends on the smoothness of the surface. That means there are some factors that affect the friction. And what are those factors? Let us see. See, one activity is given over here. Activity 12.2. Take a string around a brake. Pull the brake by a spring. Balance. You need to apply some force. Note down the reading on the spring balance. When the brake just begins to move, it gives you a measure of the force of friction between the surface of the brake and the floor. Now, wrap a piece of polythene around the brake and repeat the activity. What you will see? What you will observe? That in the reading of the spring balance in the above two cases, what might be the reason? There is a difference. What will be the reason? What do you observe? That we see that the brick when wrapped around a polythene will move easier. That means when the surface becomes smooth, the lesser of the force is to be applied to pull the object, isn't it? Spring balance, you know what is spring balance? Now, students, this is a new term for you. You can see when the school starts, we can show you this spring balance. It is there in our physics lab. It is a device used for measuring the force acting on any object. How much, sometimes you might have seen this type of device where some weight is also been done. In some gunny bag or something is to be put on the hook over here, hook provided below, and we come to know that how much the weight of a substance is, isn't it? So, this type of spring balance are there which measure the force acting on an object. It consists of a coiled spring which gets stretched when a force is applied to it, and stretching of the spring is measured by the pointer moving on a graduated scale. The reading on the scale gives the magnitude of the force. Magnitude of the force means how much the force is there. Now, similarly, you can make another activity like this. If you slant an object, see in activity 12.3 they have shown that make an inclined plane on a smooth floor or a table, and you may use a wooden board supported by bricks or books. Put a mark on with a pen at any point A on the inclined plane. Now let a pencil cell move down this point. How far does it move on the table? Before coming to rest, note down the distance. Now make sure that there are no wrinkles in the cloth. Try activity again with the spreading of the cloth on the table. Right. Now repeat this activity by a thin layer of sand. In which case the distance covered the minimum? Why is the distance covered by the pencil cell different every time? Now, by this activity we come to know, we come to understand that if the surface is smooth, the applied force will be less. That means the friction to stop a particular object moving will be lesser. And if the surface is rough, we see that friction acts more. That means friction is caused by the irregularities on the two surfaces in contact. Even those surfaces which appear very smooth have a large number of minute irregularities on them. Irregularities on the two surfaces lock into one another. That means when the two surfaces are rough, their bumps in the surface, they interlock each other, and so the frictional force occurs more. When we attempt to move any surface, we have to apply a force to overcome that interlocking. On rough surfaces, there are large number of irregularities, so the force of friction is greater if the surface is rough, if the rough surface is there. We see that the friction is caused by interlocking of irregularities in the two surfaces, and you can experience it by dragging a mat when nobody is sitting on it. When a person is sitting on it, you have to apply more force, isn't it? So you can understand by this activity, by doing on your own, that if the surface is smooth, you can easily move, or if object is heavy, the more force is to be applied on it. If you have no such experience, get the experience now what is easier to move the box from the rest or to move it when it is already in motion. Now here it has been, you are been given one activity that to drag a mat when nobody is sitting on it and when a person is sitting on it. So you can experience this and you can see which way is more easier. The force required to overcome friction at the instant an object starts moving from rest is measure of a static friction. What is static friction? When an object is at rest. During that time also, the lower surface, when the two surfaces are in contact, the surface on which the object has been kept, it applies some frictional force. That force is called as static friction. On the other hand, the force required to keep the object moving with the same speed is a measure of sliding friction. Understood, students? So when the box starts sliding, the contact points on its surface do not get enough time to lock into the contact points on the floor. So the sliding friction is slightly smaller than the static friction, and you find it somewhat easier to move the box already in motion than getting it start for moving it, or getting it just start to move, or from one place to another, right? Now friction is a necessary evil. Now you will think that we have to apply so much of force, why this friction is there, but actually you know that it is a necessary evil. Necessary evil means though it is not good, but it is very necessary. So there are many advantages of this friction force also. Now recall how some of your experiences is it easier to hold a cooler or a glass tumbler? Suppose the outer surface of the tumbler is greasy or has a thin layer of cooking oil on it. Would it become easier or more difficult to hold it? Just think, would it be possible to hold the glass at all if there is no friction? No. Recall how difficult it is to move on a wet muddy track or wet marble floor. Suppose you are walking on a soapy water. What will happen? Will you be able to walk on a soapy water? No. When the friction will be less, you won't be able to walk. Similarly, your teacher will not be able to write on a blackboard. Its rough surface rubs off some chalk particles which stick to the blackboard. But still, with the help of friction, we are able to write the correct form of a alphabet or a letter. So, frictional force is also a must evil force. If an object started moving, it would never stop if there were no friction. Had there no friction between the tires of the automobiles in the road, they could not be started or stopped or turned to change the direction of motion. You could not fix a nail on the wall or tie a knot. Without friction, no building could be constructed. So, on the other hand, friction is an evil too. It wears out the material, whether they screws like ball bearings or soles of a shoe. You must have seen worn out steps of foot over bridges at railway stations. है ना, वो जब सीढ़ियाँ होती हैं कहीं कहीं पे ख़राब हो जाती हैं, कहीं के वो टूटी फूटी सी हो जाती हैं. So those worn out steps of over bridges are due to consistent movement on the steps and the frictional force applying on it. The friction can also produce heat. Vigorously rub your palms together for a few minutes and you will see your hands get warmer. We do this exercise during winters, isn't it? And have you seen that striking a matchstick against a rough surface, it immediately catches fire. So we come to know that friction also produces heat. All these examples are showing us that friction causes wear and tear on the surfaces where it has been applied, and it also produces heat. Now we shall discuss some ways of minimizing the friction in the following sections, like increasing and reducing friction. How can we increase this friction? When we need lesser force to be applied, we try to reduce the friction, and when we need some places to move on the slippery surface also, we try to increase the friction. Have you played the carom board and put some powder on it? So you sprinkle some powder on the carom board. It is been applied because the powder particles do spread on the wooden surface which is very polished surface of a carom board, and to increase the friction so that your striker immediately hits the particular what do you say, that the Rani or a black or a white whatever you play, that circles your striker can immediately attach to it, and you can easily get the points over there. So to increase the friction, we apply, to reduce the friction, we apply powder in it, so that slipperiness of the powder can reduce the friction on the carom board, isn't it? And similarly, to increase the friction, we see that soles are there, shoes soles are been the spikes are been put on it. When sometimes we see that when you press the brake lever, these pads arrest the motion of the rim due to friction. Sometimes you have seen that the tires of a vehicle, they have the threaded grooves. These are also to increase the friction, so that when you apply a brake, it can immediately stop and your vehicle will not meet in accident. Now to reduce friction also, some of the things are there to be used. जैसे हमने powder use किया carom board पे, similarly we can use some other lubricants like putting oil or grease. Have you seen your bicycle having a grease in your पैडल स्पाइक्स? पैडल के जो स्पाइक्स होते हैं उसके अंदर जो है वो ग्रीस लगाते हैं, ताकि आपको लेस एफर्ट लगाना पड़े, और एंड यू कैन इजीली मूव your bicycle with lesser force, isn't it? Similarly, for moving your heavy suitcases, some rollers are been put over there. Some rollers wheels are been put, so that you can easily pull or push the luggage. Here is one activity given over here in 12.4. You can see that some pencils have been put over a book. When you slide a book directly on a table, you will have to apply a more force. But when you put this rollers, the pencils, with lesser force itself, you can move the book. So we see that when one body rolls over the surface of another body, the resistance to its motion is called rolling friction, and rolling reduces friction. It is always easier to roll than to slide a body over another. The rolling friction is always smaller than the sliding friction. Sliding friction is replaced in most machines by using ball bearings. Small ball-like structures, when they are been put between the two surfaces, they can easily, with lesser friction, they can easily move the two bodies. Similarly, some common examples are the use of ball bearings between hubs and axles of the ceiling fan and bicycles, isn't it? Similarly, see, you have here in figure 12.6, you can see that ball bearings reduce friction. See how the small balls are been put, isn't it? Now you know what is fluid friction. What is fluid? We have studied it previously also. What is fluids? The gases and liquids together are called as fluids. Now you will say that, ma'am, two surfaces when in contact, you said friction will apply. How can friction will apply with fluids, gases and liquids? Yes, friction can apply with gases and liquids also, and that friction is called as fluid friction. When your body is moving in water, the opposite force of the water is called as fluid friction, and it is also called as drag. Similarly, when planes are moving or birds are moving in one direction in the air when opposing it is producing a fluid friction, isn't it? You might have seen that when you bicycle, go on a bicycle and a breeze is coming, high speed breeze is coming from the opposite direction. You need to apply more force to move your bicycle, isn't it? That is also a fluid friction. The frictional force on an object in a fluid depends on its speed with respect to a fluid, and the frictional force also depends on the shape of the object and the nature of the fluid. it is obvious that when objects move through fluids, they have to overcome friction acting on them. In this process, they lose energy. Efforts are therefore made to minimize this friction. So, objects are given special shapes. Where do you think scientists get hints for these special shapes? From nature, of course. Birds and fishes have to move about in fluids all the time, and their bodies must have evolved to shapes which would make them lose less energy in overcoming the friction. And you know what shape it is called as? It is called as streamlined shape. See, the aeroplane is also made tapering towards the front and tapering in a conical way at the back too, isn't it? So the conical way of the beak is also very pointed one of the birds to reduce the friction. It cuts the drag, cuts the friction of air opposite to in the direction of the movement of the bird. Similarly, in the fishes also, the conical shape of the fish in the front is used to cut the frictional force of the water. So, in the similar way, the vehicles are being made they are designed to have such shapes which reduces the fluid friction, isn't it? So, here we have ended the chapter, right? You can read the chapter, and if you have any queries, you can ask your respective science teachers. This is a very small chapter, so I completed in a one class itself, and I am giving you some of the questions to do, very small questions I am asking you to do. Just listen to the video and complete your exercise of question 3. Till 3 exercises are there, 3 questions are there, sorry, in this exercise. Fill in the blanks, then choose the correct option is that, second one, and third one is also some example type are there that you have to mark which one is having in the increasing order which of the surfaces. So, this 3 questions you have to do in your notebook, okay, as day after tomorrow is tomorrow is Sunday, and Monday we are having a live online class. So, we will meet there, and I will give you some more questions on Monday. Saturday and Sunday you complete these 3 questions and listen to the video, isn't it? And thank you very much.